All right, so my name is Andy Klein. We're going to talk about hard drive stats. I'm going to spend a little bit of time going over them, just so you know what we collect and what we do and all of that kind of fun stuff and what we've been doing. We'll talk about how we compute failure rates, because that's always a lot of fun. Then we're going to do a little conversation about SSDs and what we know about that. And we'll get back and do a few more stats about hard drives. And then because every presentation has to say AI in it, I will do a little bit at the end, just because. That's me. I went from developer to sysadmin to marketing to drive stats guy, so I've gotten stupider as I've gotten older. Take what you will. All right, so the environment that we're dealing with, right? Right now we're up to, well, as of the 1st of September, about 256 different hard drives, different drives that we have. About 3 exabytes of storage, that's nice, and 5 different data centers. So that's the amount of data we're playing with, that's the amount of drives we're monitoring, all of those kinds of things. We have a lot of fun with that. We do have, I wanted to point out just because it's fun, we do have a data center on the water. This is Nautilus, the Nautilus data center out in Stockton. It's actually in the port of Stockton. And we are in one of the suites over here. Actually kind of cool. It's really awesome because we save a bunch of electricity doing this. It's all, and it doesn't bother the wildlife. The fish don't mind. So always good. Interesting that we'll be able to do something. I'll talk about this a little bit later, but one of the things we can do is start doing temperature by data center. So we can take a look and see, hey, is it doing what it's supposed to? Are we getting the right numbers? Are we keeping the drives happy? And so on and so forth. But we'll do that a few weeks, probably. So next year, we can talk about more of it, or you can read all about it. All right, so what do we collect? We use something called a package from SmartMon Tools called SmartCTL. We collect each day, we collect the smart stats off of every single drive that we have running, right? So you can start to do math in your head and say, well, that's 250,000 drives, that's 365, that's a lot of stuff. And we've been doing it since April of 2013. So we have a lot of data out there. That's where we get all of this information is. The data is open source. We host it, and our friends over at SNIA host it. And so if you are so inclined, and some people are, to download all of that and go play with it, you're more than welcome to do that, and make sure I'm telling the truth, because not that I've been known to lie, but I I want to make sure I'm telling the things the same way as everybody else. So the data is open source. The data structure, oh good, we have little highlights this time, and no lines. That's funny. I did a presentation similar to this a few weeks ago, and I didn't have any color, I just had lines. So I changed this one to add a lot of color and a lot of things, and all the lines disappeared. So you'll just have to follow it across. Each line is just a report from data. You can see what we collect, date, serial number, model. We add those in, obviously. The interesting thing is one line is what we call a drive day, and you'll hear me use that term. So in here we have 1, 2, 3, 4, 5, 6, whatever it is, 6 drive days. If you notice, there's 2 there that are highlighted. Those are both the same model number. So when we start to talk about things like, hey, what's the failure rate of a particular model number? That's how we group it up, okay? So it's not exactly sophisticated. And you'll notice one of them has a little 1 in the failure column. That's the brilliant designation that that drive has failed, all right? And the next day, that drive will disappear. So on this day of March 15th, that drive failed, or it actually might have failed any time in the previous couple of days, but you get the idea. And then it disappears, hopefully. No, it disappears. So that's how we collect the data. That's how it's organized. Recently, in Q2, we added a couple of new pieces of data. So let me be clear. Our operations guys always had this stuff. Okay, all of this wonderful data that I'm about to talk about. But they had to give it to me. And we played this game of I had to know to ask, which is sometimes a problem with developers. We have all of this stuff, but you should just ask for it. I didn't even know you had it. So I got the Vault ID and a pod ID. And a Vault is just a way we organize data. Data comes in, it's spread out across 20 vaults. That's called a tome. There's all kinds of things like that. But that gives us a location within a data center of where it is. And then the pod ID is just a storage server ID within that 20, right? Coming soon, data center and server type. Data center, so I'll actually know the data center. Where these drives are. So we can start to do the analysis a little deeper than we have. People have asked for that over the years. Hey, is there differences between your data centers? Now we'll know. Server type is, we have 3 different types of servers. We have our beloved Backblaze storage pods, which many of you probably know something about. We have different versions of that. We have some Dell servers in there. We have some Supermicro servers in there. So we'll be able to start to look at failure rates on a platform. Interesting, okay? As I caution everybody, I literally have 1 quarter's worth of this data right now, so I can't come up with any miraculous kind of things, but over the time we'll get it. But we'll talk about what we got today. This is what a failure is, okay? And there's 2 classes of failures for us, okay? There's a reactive one, which is it's broke. Don't talk to us, whatever the case may be, classic, right? And then there's something called a proactive one, which is we have a whole bunch of triggers. Usually it's an ATA error of some type or a file system check that fails or whatever, something squawking. And then we combine that with the data we get from smart stats, right? And we make a decision to pull that drive. We also make a decision at that point to test that drive after the fact, okay? And in 99% of the time, that drive doesn't meet manufacturer specs and it goes home. Every once in a while, one passes and we kind of put it aside, and maybe if we need it in a case of emergency, but that's how you get a 1. You fail one of those 2 things, okay? And we do all of that to do this little math that we do, which is compute something called an annualized failure rate, all right? So you'll see that, and again, we can just grab a cohort of drives. Give me drive by model, in this case, give me all of the models active as of 6/23 for the quarter, right? And we can look at the data anyway. You can look at the data anyway. It's not particularly hard. The thing that usually bothers people a lot is we don't care what drive count is, okay? Because we don't need it, okay? We use drive days and drive failures. The reason we do that way is over that period, even of a quarter, it's a very dynamic environment. We're building, adding new drives, we're taking out drives that are migrating. Drive count doesn't do very good with that, okay? Because you're gonna grab a number, what, at the end of the quarter? What you have at the beginning of the quarter? What you have on the 3rd of March? So you gotta use drive days. It gets us a number, and that's what we publish. So that's how we go through all of this. So every time you see AFR, failure rates and stuff, that's how we count it. All right. And then we publish them. Most of you have probably seen them. They're quarterly reports, annual, semi-annual reports, depending on what they are. And they kind of look a little bit like this. This is a quarterly one for Q2. There's more to it. I just wanted to point a couple of things out. Okay, but this is what we give you. And then I point these out because people look at them. Yeah?
You said, sorry, maybe I just checked. You said drive count, or drive days. Does it mean the number of days the drive has been inserted in production?
Yes. Yeah. In operation, that's correct. Yeah. So the drives appear in that data set, if you will, only if they're operational. Obviously, if they've been taken out for migration purposes, they're gone, and they no longer count. So HGST, for example, oh my goodness, look at that failure rate. I'm going to throw those things out. I get this all of the time. Look, because it's 13%, why would you ever use that? Well, I only got 8,000 drive days, okay, which is not a big number. In a quarterly report, you want 50,000 minimum, okay, minimum. And then down here, just to counter it, we got the Seagate one. Oh my goodness, that must be the best drive ever. It hasn't failed. It's only got 12,000 drive days. So when you look at these, just a little grain of salt. and see. And what I always tell folks with these things is we're not making any decisions here. This is information. You use it however you care to. Some people think it's religious and they want to see it every quarter and they buy things based on it. Okay, great. If you think so, there's a lot, but there's not a lot of information out there. So this is our contribution to that. The other one is lifetime. When we do lifetime is from when the drives first were introduced all the way to the current, in this case, the end of Q2. So we accumulate all of that data for that period, for that drive, and then we can do something called a confidence interval, which gives, because we have enough data to do it with. And then I want to point out a couple of good things. The red ones, or magenta, is, look at how wide that is. That's 10. That's 10%. That's a garbage number. Don't even look at it. Okay. Okay. So it gives it an AFR of almost 6.5%, but the value of that number is pretty low. Okay. But when you get into something like this, which has a confidence interval of 0.2, that's solid. Okay. That number there is probably pretty darn good for a failure rate. I tell people go up to about 0.5, 0.6 in that confidence interval. Anything above that, okay? And you can look at it. So here's, for example, that's the Seagate one that had no failures, but it has a confidence interval of almost 4. That's, yeah, you know. So, but you get something like this, that's 1. That's right on the border of being a decent number, okay? You got the, one of my favorites is 6 terabyte Seagate. Looking at 0.4, 0.9, those things never fail, but pretty good drives. And just for the fun of it, I make up a list, and sometimes I publish this of the best drives because some people want it. So you can see the 16 terabytes. The criteria is more than 2 million drive days. The AFR is less than 1%, the confidence interval is 0.5 point. So these are pretty solid numbers all the way around. And you can kind of see what's there. The 16 terabytes, some really good drives. Got some little footnotes like that very first one. Good drive, you can't get it in the US. You can get it in Europe, it's a server drive, and you pay about €450 for it. So chances are you're probably not gonna want it. But that's because it's actually sold via Dell. It's a long story. Anyway, 14s are good numbers. You start to get into the 12s. 2 of those HGST drives are no longer, they've been rebranded as Western Digital. Okay. Western Digital is, HGST/Western Digital is a little slow about revving model numbers. So they'll use a model number for a long time. Seagate is actually pretty good about revving model numbers. So they'll move them out. So that HGST drive, how solid that number is, if you could buy one today, is okay. And then the bottom ones, you can't find them. They're all going to be, if you find one, it's going to be a rehab drive, and these numbers don't mean a thing for rehab drives. Okay, and of course, this is all statistics and magic, and your mileage may vary. So I'll leave it at that. All right, so let's talk about SSDs and so far. Yeah.
One questions in the middle or at the end?
Let's do them at the end. I think I can make that work. Yeah, we can make that work. All right, so SSDs. So we all know these things, right? Okay, SSDs are fast and they use a little less electricity. They cost more. We didn't know anything about reliability. We didn't have some good numbers on that. So we went through and we only have SSDs as boot drives. That's what we got. And our boot drives are better than just sitting around waiting to boot the server once every 6 months or whenever you turn the darn thing off. They actually work every day, okay? They're writing log files and so on and so forth and access files of various different types. So they're doing reading, writing, deleting on a regular basis. So they're kind of like what you might have at home. Maybe a little bit more work than that. But so we decided to compare them, okay? Now we had HDDs, hard drives used as boot drives from back forever when we first started. We only started using SSDs in 2018. and we switched over, and it's just a price point kind of thing, right? So the comparison was a little funny because we had drives that were hard drives that were 8 years old, and then we had SSDs which were 2 years old. And so it's not fair to compare them, so you have to kind of make them all the same thing. So in the first year the HDD was in existence, do this, and then the first year the SSDs, and then you can compare them. So that's the kind of math we did. Okay, and we plotted them out. We said, okay, after the first year, you can kind of see the curves. The red line is the HDD line, so on, and the blue one's the SSD. And we said, okay, first year, about that. They all kind of went, and they were about 0.5%, but still pretty good, right? They're really, do I want to say anything about reliability based on that curve, okay? And so after about 4 years, we got that. And so the question came up of, okay, well, what's going to happen next? Is it going to rise? Is it going to just, SSDs are going to continue to fail like this? Or are they going to do something else, right? And what we came to find out was the answer got pretty clear. It was D, okay? And they've been pretty solid. Even the most current numbers on the SSDs, they're still right around 1%. So they seem to do pretty well. They seem to handle the load, and they're both a similar type of loads for at least this particular thing. Now, again, these are smaller drives. These are like 250 gig, 500 gig kind of drives, maybe 1 terabyte drives. They're smaller drives. So that's the comparison. That's what the boot drives are for. But it looked good for a while, and then the SSDs just finally took over, and that was the end of it. So,
Are those both full failures and those proactive?
Yeah, exactly. And we don't get as many proactive ones, to be honest with you, with the SSDs. That they just seem to wake up one morning and go, I'm done. Whereas the HDDs, you got to tickle them a little bit in order to make sure if you know they're going to fail or not. So. All right, so one of the things we've done is look at the smart stats of SSDs, okay? Because we've looked at them for hard drives for years and tried to figure out how useful they are. And so we decided, we looked at the smart stats for SSDs. And I will tell you, let's just say they're not as consistent as you would like. Different manufacturers use different numbers. They use different numbers for the same thing. They reuse numbers. Stats, it's a little interesting. There's a post that I wrote on it, but I'll pull out a couple of fun ones for you. So we picked out 3 drives, okay, and all of them happen to be 250 gig drives, which is great, all right. And we looked at them. We said, okay, so what smart stats are we getting? Smart stats come in pairs, right? They come in a raw value and a normalized value pair. And there's 255 sets of them that you potentially can have. But for example, the Seagate Barracuda one had a total of 20 pairs. That was it, right? But the other guys weren't exactly crashing the gates either, 25, 23, right? So this is what we're getting reported back to us from the drive. We say, hey, what do you got? And he says, this is what I got. And we looked at them and we said only 5 of those are actually common for all 3 models. So, for example, this 20 here, 5 are common for all 3 models, and that means 15 were not. Okay, some were only Seagate, some were paired with SDC, Western Digital, some were with Crucial, although Crucial seems a little more of an outlier, and so on. And it got wilder depending on the different drives. When you look at Micron, and they got another whole set of things, and so on and so forth. I actually put a chart in that post. It said, this is what we found. Good luck. And so I wanted to talk about the ones that I kind of thought were interesting. Okay, I'm not going to go through all of them, but they were kind of fun. One was the concept of lifetime percentage. Either how much lifetime is remaining in the SSD, or how much is used, depending on your point of view. So you can see, first of all, they all have different numbers, different pairs, different smart values that they're using for approximately the same thing. This Western Digital, right? The normalized value starts at 100 and goes down. You can see what it uses to calculate its program array cycles and available reserve blocks. And it uses a combination of those in some way to calc that number. All right, so over time, what will happen is as that drive is being used, right, that 100 will become 99, 98, and so on and so forth. The raw value goes up. That's what's supposed to happen, okay? The Seagate does a very similar thing, except that it gets to 10 and says, by definition, when you get to 10, that thing's done. Okay, Western Digital says you can get to 0. By the way, you can go past 0. You can't really, it gets to 0 and just stays there. And the drive still works. Even though Seagate suggests that they might turn your drive into read-only when you get to 0, no. Because we've been to 0, okay? So, and that's part of the interesting part about all of this, by the way, is the documentation on this stuff is really hit or miss. Okay, Crucial, Micron do a fairly good job. Seagate, Western Digital, it's like a ghost paper. The fun one was, the Crucial one, like I said, they started at 0 and went up. So when you buy a new drive, it starts at 0 instead of 100, and then they go up. And the funny thing is they can go past 100. So I have drives running at 160 or 250 or whatever the case may be, right? So I don't know why, but they have a number like that, right? So that's what you're faced with when you're trying to do smart stats for SSDs, is this kind of stuff. So I pulled a couple of other interesting ones that I thought were fun to talk about. And a couple for each of them. 230 for Western Digital's, right? It's the lifetime protection status. That sounds like it's really, really cool. It's, wow, the idea that you can have a number that kind of tells you, right, how you're doing against some trajectory. That sounds good. Am I abusing this drive, all right? Or am I not putting it into enough work, you know? But that implies a couple of things. One, they do a calculation to create that, and two, they have a curve. Okay, now I can't find anything about what that curve is, all right? So I don't know if it's, for example, based on warranty. You know, you get a 5-year warranty, we're gonna go from 0 to 100 right on a straight line. I don't know, okay? But they have one, and they have a number, and you can look at it. If you have a Western Digital drive, and you can decide if how badly you're beating your drive up. Endurance remaining, right? That's actually not a particular, it's kind of a good number because it talks about program array cycles as part of the calculation. It doesn't consider this the reserve blocks, which is the way SSDs work, you all know that, is they start using it and then they wear out a section and they grab a reserve block and they use that instead and so on and so forth, right? So this is talking about how fast basically you're erasing sections of your drive and rewriting stuff over the top of it. And so it could be useful if you're really beating up a drive to understand that. And again, that's Seagate and Western Digital. If I had a Western Digital, I'd probably go there first. But, and then the last one is the RAID one from Crucial. I haven't seen this anywhere else. It's RAID built into an SSD. It's kind of cool, right? That implies that when they write some data out there, they actually put some parity along it. They have a place to put it. They have a couple of parity blocks. They stuff it out there. And then they can self-recover without you ever knowing it. So suddenly they go to read that file and they got a bad block or a bad page or whatever it is. And they can remanufacture that data and give it back to you and you don't even know it happened. Okay, that's pretty awesome. What I couldn't figure out was whether or not they over-provisioned the drive to do that. So 250 gig was actually 300 gig, they used 50 for that, or that was just part of your 250.
It's for doing parallels in between the data chips. All the drives have that.
Okay, good. Now there you go. So now I know. All right, so this question comes up from time to time about SSDs. Remember, you all had hard drives and you had external hard drives, and you take them and you put some data on it, and then you put it in the closet, or you'd put it underneath your desk so it wouldn't wobble, whatever the case may be, and you'd leave it there for a while, and then 3 years later, you'd go back and plug it in, and sometimes it would work, right? And if it didn't work, then you got out your favorite utility and tried to figure out how to get the data off. Well, the same thing people are now doing with SSDs. They fill them up and then they stick them in the closet or they put them under the desk, and then they go back 3 years later and they cross their fingers. And nobody really had a good sense of how long that time was, all right? I've heard people say, I've done it for 6 years, and all of this kind of stuff. And other people go, I did it for a week and it didn't work, right? So I went and I found some really good information, by the way, on a crucial site when I was doing this, and they kind of came up and they said, here's the way we're going to handle it. It's a year. If the drive is new, and they went right to 202, Smart 202, which we looked at before, or earlier, which was their calculation. Remember, they're upside down on that one, right? So if it's 0, in other words, you basically haven't used the drive other than to write a little bit of data on it, you can take it out, store it for a year. You should be able to plug it back in and get your data back. And then as that number goes up to, there it is, 100, right? It's 1 month or less. Okay, there was no documentation for these two, for Western Digital and Seagate, but if you apply the same logic in the same time span, you can kind of see by looking at their particular stats what kind of number you would get, right? So a year is the recommendation by anybody who will recommend anything, and it's probably depends on how much you beat up that drive before you put it away. All right, so if you really are pounding that thing every day, doing whatever you're doing with that, and then you stash it away, and it's a little ragged, you might want to think about plugging it in every so often just to make sure you don't lose the data that's on there. All right? Yeah, we're doing fine. All right, so let's go back to hard drives since we spent enough time on SSDs, and talk about some fun stuff about those. The folks over at Secure Data Recovery published an article, let's say 4 months or 5 months ago, and said, hey, the average age of the drives that we acquire, okay, that are failed, the failure was 2 years and 10 months. So the average age of failure, okay? And they didn't describe anything like what the drives were, whether they were SSD, what their size was, or anything like that. They just published the number. So I said, well, I have data, so let's go see what we can find out. So I tried it, and I took all of the failures we ever had, and I said, what was the average age? And it came up with 2 years and 6 months, and that scared me, because I just thought it was going to be a higher number. Okay, I just did. And I went, I must have done something, and I ran that math multiple times, and I went, something's goofy, right? So then I said, oh, wait, a lot of these guys are still in operation. So they could keep failing. So I'll just take the drives that no longer are operational. So like my 2 terabyte drives, I don't have any running anymore, right? So I just use those drives. And it came up to a whopping 2 years and 7 months. so I went, all right, I got to take a little bit further look. And I came up with this little chart, okay? And the magenta numbers are the drives by size that are no longer running. I don't have any of them running, okay? And you can kind of see that's the numbers that made up that failure rate of 2 years and 6 months, 2 years, 7 months. And then the blue ones, right, are the ones that are still in operation. And you can tell already that that number has to go up. Has to, okay? Look, the average age of my 4 terabytes is 7 years. Right? If any of those fail, chances are they're going to be more than 2 years and 7 months because I haven't put any in the last 3 or 4 years. So chances are the number's going up, but I don't know what it is yet, okay? I'll probably get to their number, which will be funny as hell because I just thought their number was real. I thought the number should be like 3.5, 4 years. Just, you have a hypothesis, you can go. And so we'll keep an eye on it and see what's going on. I want to shout out to my 6 terabyte drives with 8 years in and cranking along at a very nice rate. You can't buy those anymore. I have all of them. So they threatened to take them out of the data center because they're migrating drives, of course, what they have to do, right? The 4s are starting to come out, the 6s are starting to come out, the 8s are even starting to come out. And they say, well, we're getting ready to work on the 6s. You leave them alone, okay? Let's see how long those guys go, because they're working. You get rid of some of those cruddy 4s in there. So, all right. So the other fun thing we looked at was this thing called the bathtub curve. You guys are all familiar with it, right? Early failures, infant mortality failures, nice settle in a period of time, and then random failures, and then things start to wear out, right? That's classic. And so we've revisited this from time to time, okay? And a few years ago, we matched it almost perfectly. It was really great, all right? And then when we ran it this time, we got something that looked a little more like a ladle. And the front end of the curve dropped, basically, okay? Now, I personally think that's the drive manufacturers in particular doing a little bit better job up in the front end of testing their drives and making sure they're not sending you boxes of broken things. I spent some time at the Seagate facility in Longmont, Colorado, where they do prototyping and they do a bunch of testing and all of that. And I watched the process that they put the drives through, and then they replicate that supposedly out in the field when you manufacture them. But basically, a drive comes off and it gets put in a little box and it gets subjected to testing and a little bit of heat and all of that before it's actually ever put in a box and sent to a person. That's supposed to be what happens. I didn't go to the actual factory, so I can't swear on that. I'm just telling you what they told me. But if indeed they are doing that and the rest of the manufacturers are doing something similar, then that front end of the curve should come down. You should be able to find those DOA guys before they get to your house. The interesting thing about this curve, though, is if you kind of draw a little line out between the front and the back, you actually get a wonderful little bowl there, okay? And that's at about 4 years. And that's probably a really good point, because the data out here starts to get a little loose. And what I mean by that is we don't have a lot of it. So this number could be, that failure rate of 7% could be made up of 50 drives, whereas this number down here could be made up of a couple of 500 or 700 or something like that. So the accuracy is, so you still get this bowl kind of shape, you still get the curve that's there, it just, it happens in that given period of time. Which is a little shorter than the warranty period for most drives, especially enterprise drives, which is 5 years. So I'd love to see that stretch out to here. Okay, so we'll see how that goes over the next few years. We currently use enterprise drives. I know we started out 1 million years ago using consumer drives, and by the way, they seem to perform about the same. But we were getting really good prices on consumer drives. Now, because we buy a lot, to be quite honest with you, we get good prices and we don't have to worry about the consumer drive stuff. So we're using enterprise drives. So go tell your friends. What can I say? All right. So AI, because we have to. No, it's actually kind of interesting. So way back in 2016 was the first paper I ever saw that was done on predicting hard drive failure using the data. Okay, so all of this data, people just take a look at our data and have a good old time with it, right? And that was more traditional methods, multi-regression analysis, all of those kinds of fun stuff, right? And then over the last several years, people have started to use the data into some type of an AI, ML type of application. Now, one of the things they find is, one, you actually can predict drive failure, but two, you need a lot of data to do it, all right? So that's kind of useless, all right? If it takes me 3 years worth of data to find out that in year 4, I'm gonna fail at a certain rate, I don't know if that's helpful. And so a lot of them have tried different methods to try to get that number down, the number of observations down. And one of them that did a pretty good job of it was something that was written back in 2021. I happen to like this one because I could understand it. It wasn't a black box. It wasn't an AI black box where you just shoved in a bunch of numbers and you got answers out the back side of it. And so they use two concepts with I'm sure most of you are familiar with. They use decision trees and survival curves. And there's a little bit of magic going on in there, don't get me wrong. But it's pretty straightforward to understand. And so they build a decision tree with the data. So they just start flowing data through, okay, and they have the various attributes here. And these all move around depending on how the data comes in. And then these numbers move around. So plus 12, greater than equal 12, greater, so on and so forth. Those numbers move around as they push the data through for a particular model, for example. And then they land on a chart that looks like this. And then at the end, they come up with, and I just picked out a couple of the nodes at the bottom, okay? A low number, no, it's really crappy, you'll see. A high number, you'll see really good stuff. So, and I put those aside here because they can do something, okay? In this case, the number of observations was 50,000, which in our world is pretty darn low. That's 50,000 days worth of data, 50 drive days worth of data for a particular model. And that's a real doable thing. We can give them that number. And here, for example, they can help us predict healthy drives. So drives that look like they're going to last. They're going to be around for a while. Yay, good. Okay, I like that. And they give you a certain expectation and they give you a number. So you see they counted almost 5,000 drives, which is a pretty decent number to be working with for a particular model. And it's all based on smart attributes. All right? So if a particular drive has this set of attributes, meets this criteria, that's your survival curve. Okay? Not bad. The opposite is also true. You can find unhealthy things. All right? And obviously this is a little more important. And the reason why, by the way, this is a big deal for us, and it's a big deal for everybody in this business, okay, is to understand what's going to fail before it fails, and then get it out, is because we're all running into the same thing. We have this, when we had a 1 terabyte drive or a 2 terabyte drive, you could rebuild them in a RAID array, or using something similar to that, in a day. All right, you could fill that drive up and you could put it back. It could fail. You could pull it out, put a new one in, and that drive would be rebuilt in a day. All right. When you're talking 20 terabytes, it's not a day, and it's not just 20 days. Sometimes, okay, you could be talking 3 to 4 weeks to rebuild that drive. Okay, it's just because you have a busy system. You can't shut your system down. It takes a while to go and rebuild all the content. So when you fail a drive, and you pell it out, you put a brand new one in its place, 3 weeks, right? So what can you do? Well, if I anticipate the failure of that drive, and I yank it out, and I clone it, which takes a day, and I put it back in, and it takes another day to kind of fix what it missed in that one day, that's 2 days instead of 20, right? So that's why knowing what's coming is really, really important, all right? So as much as we publish all of this wonderful data and people read it and all of that and all of the excitement and everything like that, internally, this is key for us. This kind of stuff is key. Knowing that that drive is going the wrong way, getting it out, getting it cloned, getting a new one, getting the clone back in there and getting it up and running keeps your durability up. Okay, durability is the ability to recover, not lose a file, right? And when you're running on, 15 data, 5 parity across the 20 thing, you can lose 5 drives, okay? The statistical chances of doing that are really ridiculously low, but it's not 0. So as the guy says, you mean I got a chance kind of thing, right? So this is why knowing this kind of information for us is really, really important. All right, so I finished a little early. That's okay, great. All right, so we talked about all of these kinds of things. There was a couple of folks who might have had some questions, and if you do, feel free to shout them out, and we'll go from there. Yeah.
So you're running tens of thousands of drives of a certain type, and you run them probably, presumably, beyond their warranty period. What happens when you see the hockey stick curve start, and you say,
yeah,
oh, all these drives I bought 7 years ago, they're all failing right now.
Yeah, so good point. That's why we have people. And we do see it. We first saw it way back in the 1.5 terabyte days when we were doing that, and that exactly happened. We got to like 28 months on a 2-year warranty period, and they just started to climb. And it's all hands on deck at that point to get those drives out. We obviously keep a large amount of drives. We also spend a lot of time migrating drives. We also have some software that I'll actually talk about over the next few months, something called CVT, which is the migration software, the ability to take an entire vault of files, and a vault is 20 servers all working together, and migrate the data off of them instantaneously. So if we had a circumstance like that where a particular group of things would be, first of all, they'd all be in the same vault, okay, because of sizing things, and you can take that out and copy that data and get it copied over and running and operational I think we're down to about a week now. So, especially on the smaller drives. So it's a good point because we saw it way back when and we went, okay, we got to be ready for this. But it does happen where they just hit the wall and they hit it hard. And one of the things we do is internally we track the period, the most recent failure rates, so you can start to see that curve as it starts to come up. And then people go and dig in and go, what's going on? How old are these things? Should we move them up in the schedule? You know, those kinds of things. So the ability, we're still small enough right now to be able to insert people in the process pretty quickly and make decisions. I don't have AI software running in the back making all of this stuff. We have some very good software that helps identify things, but we still use bodies and experience to kind of make some decisions. I know we're starting to look at some of those other tools because that's what the world's doing. But we've seen it before. We know what to do with it. I think we have the right tools in place. So it's a good question, though. Yeah.
Do you see a lot of press out there now about people running data centers hotter and hotter, trying to economize. Do you still run yours at a certain temperature, or do you let it fluctuate more?
So across the board, because until recently I couldn't do it, we were running at someplace, we started a couple of years ago at about 29 degrees C. We're up to about 31 right now, and everything seems to be fine. I'm going to look at it by data center to see. I'm particularly interested in the Nautilus one to see where that lies. Those are fine numbers. I mean, you're talking 80 degrees, 82 degrees, as the drive temperature internally. And that's what we monitor. We have seen that SSDs run hotter in our particular environment by 4 or 5 degrees. So we'll have to see how that pans out, because once you start to get to like 40, manufacturers aren't happy. They spec it at 60, okay? And we've plotted the curves out before, and most of the time you never see anything above 40, and if you do, it's a couple of scragglers who had a bad day, or they're failing. And drives have the tendency, we haven't seen the relationship between failure and heat other than, because you don't know which one happened first, okay? But we'll be able to, but we see that. So about 45 is where we cap out at anything. From 45 to about 55, we monitor things, and if anything happens to get into that, people start paying attention. At 55, we set the triggers off.
Is all your monitoring done through drive electronics, or are you using SCSI enclosure services?
We're using we do two things. Obviously, we monitor the data center air ambient temperatures and all of that, and then the drive temperatures internally themselves. So those are the two things we monitor. So yeah, I think you were next. Yeah.
So do you do any rest display stuff? For instance, drives these days, as you start looking at the really big ones, they'll give you if a head surface go out, you can basically turn that surface off.
Yeah, no, not yet. We've talked about it internally. No.
So,
Yeah.
one of the fun things that's in there that might be unexpected to you is that the drive makers have demanded the ability because they actually encode the available capacity into the model number.
Mm-hmm.
So if you take a surface out, they'll change the model number on you. You're really mess with your stuff. You might want to talk to them about that.
Yeah, we'll have that conversation. So one of the things obviously we've developed over the years is a reasonably good relationship with all three of the major manufacturers, right? So we know what their tech, we know their techs, and they give us folks to talk to and all of that, and you always have that, by publishing this stuff, by the way. I don't want to say we keep them honest or anything like that, because I'm not sure that's possible. Sorry. But there are any drive guys in here. Thank you. I apologize. But we, but you have a love-hate relationship with them in general anyway, right? But all of them have been good about working with us and trying to solve problems, and so hopefully they'll let us know when they're planning on doing that, if they haven't already, and we'll find it out. So
The second thing was, do you know about JDSD 218?
no, I don't. No.
Okay, so that's a JEDEC spec which talks about the retention time on SSDs as a requirement, either for enterprise or client drives. And for enterprise, at the end of what we determine to be end of life is when the device gets stored at 40 degrees.
40.
centigrade.
Wow.
How long a retention you'll have at the end of life.
So they factor temp in. Okay.
Oh,
Yeah.
It's actually, we do a huge amount of qual to get there.
Yeah. Oh, by the way, that's a good thing. All three of those drives were consumer drives that I pointed out. Okay. So, take that with a grain of salt. I think there was a question back there. Yeah.
Oh yeah, can you pull back the slide with the smart stats, with the AI? The one with the attributes?
Oh, the attributes. Yeah.
It was like towards the end.
Oh, that one.
No, it was the 87.
Oh, I did. Got it. Okay. Sorry. Misunderstood. This one or this one?
Yeah, so I was gonna say, like, for SSDs, these kind of are not standardized for SATA, and
Yeah.
the only way to get like a standard output would be to use the extended logs.
Yeah. Yeah.
I think that's a better way.
One of the things that we've seen already is each of the SSD manufacturers has come up with their own smart stat tool set, whatever, monitoring set. And the generic vendors, Smart CTL and so on, have to try to catch up with them, okay? And it's not like they're the Microns of the world are broadcasting. Guess what we did? So you just have to basically go buy the drive, see what you get, okay, and then update your stuff.
So I guess my question would be, what are these attributes?
So these are smart attributes coming from hard drives in this particular instance. I don't include SSDs in this. Which model did they use here? They use a 12 terabyte Seagate model for this particular analysis. So they're doing it model. One of the things that we found over the years with the AI studies that I've read is they can do pretty interesting things with a particular model, but they can't get the transference to another model to work, which is a real key ingredient with being able to do AI predictions and stuff. And it's just got to do, I suspect, with the fact that model numbers are, kind of a shot in the dark sometimes about whether or not what they changed and what they bothered to tell you about and so on. So let's see. So we got like one more question maybe. Yeah.
So for SSD, do you publish failure rates?
Yeah.
Like, a little different than HDD. Do you publish them based on their wear? More
Yeah.
two-dimensional.
It's the same mechanism, same thing. They ran this far. They have this many drive days. And this many failures. Yeah.
So at 100% warranty, you just write those off?
No, we run them until they die. It's the same thing with hard drives. The only thing for the SSDs and boot drives in particular, because their function is never, they could die and we don't care, okay? We'll just wait until that drive needs maintenance and we'll off the log file somewhere else and everybody's fine. And then when we go, we'll pull that thing out, we'll fail it, and then we'll put a new one back in. So it's a little bit different. It's an interesting point to talk about whether it's 100% to your point.
Yeah, I think it's more two-dimensional with SSD.
Yeah,
because
yeah. That's actually a really good insight. I like that. I'll have to see if I can pull that one off. So there was one more question, real quick.
Because, yeah, so you said you have a very large drive taking a long time to do it. Do you have data schemes that can survive multiple drive failures, like 2 drive failures?
So when a drive fails, we take it out of service. Oh, I see what your point is. Oh, the durability calcs. Yes, yeah, we do all of those all of the time. We have
Like
people.
if you're using RAID 6, for example, like you can survive 2 drive failure while one drive being.
Yeah, we go through a whole process it depends on the parity arrangement. We have 17.3, we have 16.4, and we have some 15.5 coming down the road. It just depends on the size of the drives. And we go through a whole parade of steps. So if you're doing 17.3 and you lose a drive, you take the entire vault and you drop it into what we call large file mode, which is you can't upload anything unless you're trying to finish a large file. You lose 2 of them, you put it in read-only mode, okay? And then you take the drives that failed and you're trying to clone them. You might drive them up to drive savers up in Novato and say, I need this now, whatever, okay? And if you get to 3, you're desperate because you can't fail a 4th, okay? And so you're doing anything you can to get as much data back onto those drives as possible. So anyway, I think we're out of time, so I appreciate your time today. I'll be here for a couple of minutes anyway, or at least outside, so thank you very much.